Okay, so this is a question from Prince, no? So, yan. He's connected on live. Okay. So, this is his question about alternating current circuits. So, a sinusoidal current wave which has an effective value of 10 amperes has a maximum value of blank. So, we are given the following choices. Okay. So, I will discuss first the alternating current AC. There is a sinusoidal current wave. No? So let's say this is a sine wave. Wala tayong ilaw. Ano yung ilaw? Okay, let's say we have a sinusoidal waveform here. We have a sine wave. So for a sine wave, so this is the positive and negative of the cycle. No? So this is a cycle. So you have a positive half cycle, then we have the negative half cycle. So this is our positive peak. This is the maximum value, no? Positive maximum or positive peak value. Then we have the negative peak value, or the maximum value. So let us consider the positive peak value. Okay, so the positive peak value, so this is our maximum value. That's our maximum value. Okay, so we have, let's say at this point, at this particular point, we have what we call the RMS value, the root mean square value, the RMS or the effective value. So what is the root mean square? Root mean square. So our root mean square is equal to the maximum value. This is the maximum value divided by square root of 2. Okay. There. And there is a lower value, no? This is what we call the average value. The lower value is what we call the average value. Average value, which is equal to 2 over pi of the maximum value. There. Okay. So again, so we have here our root mean square, or this is actually the effective value. Root mean square. So this is the effective value. Effective value. So again, that is equal to the maximum value over square root of 2. So in decimal, so this is actually 1 divided by square root of 2. What is 1 divided by square root of 2? Okay, 1 divided by square root of 2. So that is 0.707. Okay. 0.707 multiplied by the maximum value. So meaning this is the 70.7%. 70.7% of the maximum value. That is our effective value. Is our effective value. So we have here our average value. So what is the average value? Okay. So we have here our 2 over pi multiplied by the maximum value. So what is 2 divided by pi? So we have 2 divided by pi. So that is equal to 0.6366. 0.637. We can make it 0.637 multiplied by the maximum value, or in percent. So that will be 63.7% of the maximum value. Okay? So please take note of these two important formula in alternating current circuit. Okay? There. So the problem here, no? Let's go back to your question. So a sinusoidal current wave which has an effective value. So effective value. Effective value is equal to 10. So the question is the maximum value. So we'll be using this formula, the RMS. Okay, I will substitute the effective value of 10 amperes. So I will put here 10. Okay, so that is equal to the maximum value. We can use directly this maximum value over square root of 2. So we'll be having here the maximum value that is equal to square root of 2 multiplied by 10. So just cross multiply this here. Okay. So our answer here will be this value, C. So that is square root of 2. Then you have to multiply it by 10. So the answer would be 14.14. 14.14 amperes. So that is our maximum value. Maximum value is 14.14. So please, my answer to your question is letter A. Okay? That is the answer, letter A. Okay, I'll give you additional info. Okay, let's go here. Sir, let's say I have a multi-tester. So I set my multi-tester in volts, AC volts, ACV. Okay. So I measure the power or the voltage in the outlet. It registers, let's say, 235 volts. Okay. Sir, what is this 235 volts? Okay, that is the voltage measured in the outlet. Let's say you have your outlet here. Okay, then you have your multi-tester here. Sets in VAC. So we put the 2 test lead here, and it registers 235 volts. Sir, what is this 235 volts? Is that the RMS, the effective value, the average value, or the maximum value? That is a question. That is a practical question, quite a practical question. What is being measured by our voltmeter? Okay. So, remember, if you have your 235 volts being measured by your AC voltmeter, so it is our RMS value. That is our RMS value. The root mean square. Again, RMS is equal to the root mean square. Or simply, that is the effective value, otherwise known as the effective value. The 235, or let's say you measure 220 volts, you measure 240 volts. So that is the effective value. That is effective value. Okay? Say let's say, sir, I measure the voltage in my battery. Let's say you have a battery. Okay? You have a battery here. This is the positive, negative. Then We have a multi-tester here set in VDC. Okay, of course, you have to put the positive here and you have to put the negative here. Okay. Then it registers 12 volts. Let's say 12 volts. Question, what is this 12 volts? What is this 12 volts? Okay. What is this 12 volts? That is actually the average value. Remember that the average value is also the same as the DC value. Okay? Please take note of that. And the RMS value is also known as the AC value. AC value. If we mean AC value, that is the RMS or the effective value. If we mean DC value, that is already the average value. The average value. Well, if you have your AC, of course, if you want to calculate the average value or the DC value of this AC waveform, the sinusoidal wave, so you just have to multiply the maximum value by 2 over pi or 0.637. There you get the DC value. Okay? So going back here, the RMS value is also known as the AC value. That is the AC value. And the average value is known as the DC value. That is the DC value. So please take note of that. No? Okay. AC meters measures the root mean square or the effective value. DC meters measures average value. All DC meters measures average value. All AC meters measures effective value or the RMS value. It's not the peak actually. Okay. Well, if you want to know the peak, of course, you have to do some calculations here. Okay. And there is an instrument that will show to you the maximum value, even that will show the waveform. That is known as the oscilloscope. That is known as the oscilloscope. Okay? Okay? You know oscilloscope, Prince? You know oscilloscope? It is an instrument. You know oscilloscope? Prince? No?
Hindi pa, sir.
Every color, every hue is represented by me and you.
Kaleidoscope.
Ay, kaleidoscope pala. I-edit mo yung partner. Hindi maganda. Okay. So that is the oscilloscope that will show the waveform or the graph. Okay. So that is my answer to your question, Prince. No. So is that clear with you now? Did you get my answer?
Yes, sir. Yes, sir. Thank you po.
Okay. So okay. Thank you.